Friends, welcome to my YouTube channel. Dhanesh here. So today I am going to talk about convolutional neural network. So this video is an introduction to convolutional neural network. See, convolutional neural network is a type of neural network that is used in image recognition, classification and classification. So convolutional neural network is used for image recognition and classification. Mainly two aspects it's covering. One is image recognition and classification. So these two are the aspects in which convolutional neural network is used. See, convolutional neural networks, we call it as CNN, convolutional neural network. CNNs have been successful in identifying faces, objects, traffic signs, apart from powering vision in robots and self-driving cars. So convolutional neural networks are used in robots and self-driving cars as well. Lately, we are also using convolutional neural networks is also effective in several NLP tasks as well. NLP, natural language processing. Here also convolutional neural networks we are using. See, mainly from this what we understood is convolutional neural networks are used in image recognition. So main aspect is the image recognition. So let me talk some about image. See, first we need to understand what an image is. So image is a matrix of pixel values. So you know that matrix means rows and columns. So that you need to understand. Image is a matrix of pixel values. That's an image. So I am talking about image. It is a matrix of pixel values. From a computer point of view, it is a matrix of pixel values. Matrix, in mathematics you learn matrix. It contains rows and columns of data. So pixel is the smallest element of an image. If you ask what is a pixel, it is the smallest element of an image. Its value, pixel value, ranges from 0 to 255. The value of the pixel, it ranges from 0 to 255, and pixel is the smallest element of an image. Since CNN is used for image recognition, I am just giving an idea about how our computer interprets image. So image is a matrix of pixel values. And one more thing, image is there is color image and black and white images. So how these are all image, it is classified into two. You have color images, color image and black and white image. So you have two types of images. See how a color image is represented and how a black and white image is represented. See, normally the size of an image, for example, it is represented like this. You may be, it's in the pixel size. It is represented as if it is a color image. Color image will be like this. It may be, you may be seen like that, 28 into 40 into 3. This 3 represents the RGB, that is red, blue, green. If it is a color image, it should be like this. So 28 rows and 40 columns, and 3 represents the RGB. That's the way you normally represents the size of an image. But if it is a black and white image, so there is only there won't be any 3 here. So it would be generally we will write it as if it is a black and white image, you can write it as 30 into 40. So 30 into 40 pixel. So when this 3 comes, it's like the color red, green and blue channels also introduced in the case of a color image. So there is, black and white images. There it is only two channel. Color image means we will introduce the red, blue, green. That is the color, that channel also we will introduce. If generally we can represent an image like this. If you want, you can represent it like this. It is, generally it can be written as B into A into 3. This 3 is just stands for the RGB. This B, the number of rows, columns, and 3 stands for the RGB. And if I am, more precisely, you can imagine those as three two-dimensional matrices stacked over each other, each having pixel values ranging from 0 to 255. See, this color image, you can imagine it as, three two-dimensional matrices. This is it's like this. This is 3. This is the 3, like this. This is for the red, this is for the blue, this is for the green. So three, two-dimensional matrices stacked over each other. That is, the pixel, the value ranges from 0 to 255. This is what we usually see it in a color image. If it is a black and white image, it would be only, one channel. You can write it as this will be 30 into 20. So this is 1. So this is the color image. This is stands for a color image, and this is a black and white image. So why I am telling in detail, it is, the convolutional neural networks are used for image recognition. So we must be having a idea about the image recognition. So the next point I am going to discuss here is why are not fully connected networks, why we are not using for this image recognition. See, the networks, it's all about, so what we are going to discuss here is why not fully connected networks, why we are going for this convolutional networks for image recognition. See, the neural networks, it's all about weights and biases. See, you have in the architecture, there is an input layer, there is an output layer. In between, there is a hidden layer. Inside the hidden layer, all the computations and calculations will happen. And these layers or nodes are connected together by weights and biases. Those arrows, these represents the, the weights and biases. The architecture of this, a neural network. See, if we are, using to read an image of, 28 into 28 into 3, this is the size of an image. Then the weight in the hidden layer, the number of weights in the hidden layer should be 2352. This much weights we needed. See, in the neural network, this, this much weights, they are, connected between weights are the connection between nodes. So this much weights is needed for this, fully connected networks to read an image. But in the normal, case, the size of an image should be, it should start from, normally it is 400, it is into 400 into 3. This will be a huge number. It would be like 400 into 400 into 3 will be, it would be 48. Then again it is 4,80,000. It's a huge number. So that much weight is needed in the first hidden layer itself. It's a very complex process, and it needed more neurons, and it causes overfitting. So this will leads to overfitting. So to avoid this process to avoid these difficulties, or because of this problem we are not using fully connected neural networks here, and we are coming up with the idea of convolutional neural network. See how this convolutional neural network handle this problem. In convolutional neural network, the neuron in a layer will only be connected to a smaller region of the layers before it. And instead of it is not connecting all the neurons, or we can call it as nodes. Here the circles represents the nodes. See, in a convolutional neural network, a particular neuron or a node in a particular layer will be connected to a smaller region of that, the next a smaller region. It is not connecting all the nodes. So if I can pictorially represent it, you will get more clarity. We have a node here. It is like this is one node. Here we have another node. Here we have another node. Here you have, so this is another one, this is another one, this is another node, this is another node. These are all the nodes. In a fully connected network, all of them will be interconnected. But when you see a CNN, convolutional neural networks, the connection will be like this. See, it would be like this. This is the convolutional neural network. It would be like this. It's not all connected. It is the connections are less here, so we can reduce the number of weights here. See, you can reduce it. See, the number of weights, we can reduce it. That is the advantage here. This is a fully this is a convolutional neural network. So you understood here the weights is less. It is not all the layers are completely, not all the nodes are not completely connected. It's the number of weights we are keeping here, it is very less. So that's the way we improve the design. And the convolutional neural network, it's a design, it is inspired by the animal visual cortex. See, the design of this convolutional neural network is inspired from the visual cortex of the animal brain or human brain. It is from the visual cortex is behind your brain. This even the convolutional neural networks design is also inspired from the visual cortex of our human brain, or even all the animals is it works in the same way. So it's some visual cortex, how it is visual cortex are some it's behind our brain. As I told, it's just behind our brain. It's the visual cortex are sensitive to specific regions of the visual field. For example, some neurons are fired when exposed to vertical edges. Like that, some neurons are fired to the vertical edges. Some neurons are exposed fired when it is exposed to the horizontal edges, or some neurons are fired when it is exposed to the diagonal edges. So it's like, it's the way the visual cortex works. It's sensitive to specific regions of the visual field. Some neurons are fired when exposed to the vertical edges of the object. For example, if you have a square like this, or sorry, cube like this, see our visual cortex, it's these edges, it is sensitive, very much sensitive to the edges, the horizontal, the vertical, and the diagonal edges. It is very much sensitive. In that way it works. So this is that what I want to tell you is the design of the convolutional neural network is inspired from the visual cortex of our human brain. That is a very important point. And now I am getting into the another thing, the architecture of the convolutional neural network. See, the convolutional neural network architecture, if we if you try to understand, it consists of four layers. The architecture, the convolutional neural network consists of four layers. It is the first one is the convolution layer. Convolution layer. This is the first layer, very important, convolution layer. Second one is known as the ReLU. You know that it is an activation function, rectilinear unit. It is a ReLU function. It is known as it is an activation function. Activation functions in neural networks, it impart non-linearity into the network, our non-linearity into the neural networks, and it decides whether a particular node or a neuron should be activated or not. Based on this activation function, whether a node is activated or not, it decides the activation function. It determines the state of the particular node, particular perceptron. I can tell you the activation function determines the state of a particular node. So different types of activation functions are there: sigmoid, time, hyperbolic, tan, ReLU. All these are all activation functions. In convolutional neural network, we are using the ReLU as the activation function. When I explained the neural network architecture, we explained using sigmoid activation function. So that is the second layer. Third one is the pooling. So third layer is the pooling layer. So we will discuss in detail all these layers in the coming videos. Fourth one is the fully connected layer. So these are all the four layers, four layers we use in the convolutional neural network. First one is the convolution layer. Second one is the ReLU, pooling layer, fully connected layer. So in the coming videos, I will be covering all these layers in depth, and then you will get a better idea of how the CNN works. So that's all about in this video. Thanks for watching.